This conference will now be recorded.
Hey guys, now we're going to talk about Kafka. So let's get started. So before talking about Kafka, we have to understand about something called as messaging system. So what is messaging system and why do we need it? So I'll start with a very simple example. Let's say that in the olden days, the primary source of communication was through the telegrams or letters, right? So generally we used to write the letters and then take the letter, put it in the post box. Postman will pick it up and then deliver it to the recipient, right? So in that specific example, so you're going to act as a producer of that letter, and then the postman is going to act as a broker. It's a kind of mediator, right? And then is going to deliver it to the respective recipient. So in that example, we can hold together call it as a messaging system, because in any messaging system we'll have three components: producer or publisher, broker, and then consumer or subscriber. So producer or publisher, as the name suggests, is going to produce the data for you, right? And then coming to the coming to the broker is going to take the data from producer and pass it on to the consumer or subscriber. So in any messaging system we'll have three main components: producer or publisher, broker, consumer or subscriber, all are same. So what is Kafka then? So Kafka is actually one of the example for the messaging system. So generally in the interviews or in the projects, you might hear this terminology. Let me make a note. So in the projects or in the interviews, people may call it as pub sub model. So Kafka is an example for messaging system. So Kafka is pub sub model. So pub sub model is what? So pub sub model is nothing but publisher subscriber. Publisher subscriber, or this is also called as pub sub model in short, or producer and consumer. All are same terminology, so you have to remember this. Pub sub is a shortcut for publisher and subscriber, and it is also called as producer or consumer. So Kafka is actually based upon the pub sub model. So Kafka is one of the example for the messaging system that we have got. So these terminologies are very important, especially in the interviews as well as in the projects. People keep using these terminologies. Just remember this. Then this is how it will look like diagrammatically. So producer produces the data to the message broker. Consumer consumes the data from the message broker. So fairly simple definition. Producers are the client applications and they send some messages. Brokers receive those messages from the publishers and they store them. Coming to the consumers read the message records from the brokers. So now I'll ask this question: why do we need Kafka? So when company started, it was very simple. We have one source system and then one target system. If you want to send the data from source system to target system, it is very simple, because we have only one source and one target. It is pretty straightforward to send the data from source to the target. But as we progress through, things become complicated, because we can have multiple source systems and then we can have multiple target systems. Suppose if you want to send the data from each source system to each target system, that's where it will be a little tricky. Now, why is it so? Because we have to take care about a lot of things. Suppose I have four source systems and six target systems, and we want to send the data from each source to each target. Total 4 into 6, 24 integrations we have to take care. Now, what all each integration will consist of? Each integration will have these three important things that we have to take care. First one is the protocol. Protocol is nothing but how we are trying to transport the data or transfer the data. So there are some protocols such as TCP, HTTP, REST, FTP, and then JDBC. And then we have data format. So basically how you wanted to parse the data, or in which format you want to send the data. It can be binary, CSV, or JSON, or Avro. And then data schema, and then evaluation. So basically how the data is shaped, and the data may change over the time. So the point is very clear. We have to take care about all these integrations if we have to send the data from each source to the each target system. So what is the disadvantage of this? Each source system will have an increased load from the target systems or the connections. So that's where people were looking for a solution which could solve this problem. That's where Kafka came into the picture. So what is Kafka? As I told, Kafka is an example for the messaging system. It is based on pub sub model, publisher subscriber model. As you can see here, we have multiple source systems and then multiple target systems. We are decoupling the sources and targets. That is, we are separating the sources and targets. There is no direct communication between the sources and targets. Everything should go via Kafka only. So that's where Kafka comes into the picture. So it is mainly meant for dealing with the decoupling of the data streams and systems, that is the decoupling of the source systems and then target systems. Let's see some of the examples. So these are some of the examples for the source systems and then target systems. So you can see you have the source systems can be website events or pricing data or financial transactions such as uh, your bank transactions, right? And then user interactions. These are some of your source systems. You may wanted to push this data to, it could be a database, or you may wanted to perform some analytics on top of that data, or you may wanted to send some emails whenever there is a credit or debit, right, in your bank account, and then you may have to deal with some auditing mechanism, right? So the point is very clear. You have multiple sources, multiple targets, right? So how are we going to take care about this? We are going to take care by using Kafka, because Kafka is going to decouple the sources and then targets. So some more examples where Kafka is being used. So Kafka is used at multiple applications and we are using them on daily basis. One such example is nothing but Netflix. So Netflix uses Kafka to apply the recommendations in the real time while you are watching TV shows. Suppose if you are watching thriller genre movie, then you might get some recommendations around the same genre, right? So Netflix uses Kafka also quite a lot. And Uber also uses Kafka and sparse structured streaming. So you might have observed sometimes, right? Suppose let's say if it is Friday evening and there is a huge rainfall and there is huge traffic, you might have observed that the cab prices will go very high, right? So that is nothing but the search pricing in the real time. Search pricing in the real time is nothing but prices will increase in the real time within minutes. So again, Uber uses Kafka quite a lot to do all such use cases. Another application where Kafka is being used is nothing but LinkedIn. So LinkedIn uses Kafka quite a lot again to provide the connection recommendations in the real time and so on. So remember one thing, Kafka is just going to act as a transportation mechanism to transfer the data from your source to the target. That's it. Now, what is Kafka? As I told, it's an open source project. It was actually developed at LinkedIn, but later on it's become open source in year 2011. So Kafka is a distributed streaming platform for building real-time data pipelines. Now, why are we calling it as distributed streaming platform? There is a reason behind that. We will cover that shortly, right? But for now, remember that Kafka is a distributed streaming platform for building the real-time data pipelines. And this is how the architecture of Kafka will look like. Don't worry about this architecture for now. We will break down each and every component and we'll try to learn about each of these components now. So the first component in Kafka that we are going to talk is nothing but producer. As the name suggests, producer is going to produce the data or create the data for you. So producer is an application that sends the data. Again, some people call it as data, some people call it as message, some people call it as message record, but all these are kind of synonyms for you. So in short, you have to remember that producer is an application that sends the message to the Kafka server. So this is how it will look like. Producer produces the data to the Kafka server, and then consumer consumes it from the Kafka server. So what is a message? So a message is nothing but small to medium sized piece of data. It can be anything. So let me give one more example in Kafka with respect to Kafka. Suppose you walk into a restaurant and then immediately someone else will come to your table and then pick up the order from you. And then the same order is passed it on to the chef, so that chef can prepare the food for you based on the taken order. So again, in that restaurant example, you're going to act as a producer, and then the chef is going to act as a you're going to act as a consumer, chef is going to act as a producer. You can think of message is nothing but the food that you have ordered. Again, if you open the menu in any restaurant, you can find different categories of food, right? It can be some soft drinks, or if I talk about Indian food, it could be some starters, right? And then there could be some main course, let's say biryani, right? So the food item can be anything. It can be as simple or it can be as huge as biryani, right? So the point is very simple. So message is nothing but a small to medium sized piece of data. So these messages can be anything ranging from simple string to a complex object. So what is message? In simple terms, it is nothing but array of bytes. It's nothing but array of bytes. So let's see diagrammatically. You have this text file and each line actually represents the message for you, right? And then to talk about the consumer, consumer is again an application that receives the data. So consumers are basically nothing but the recipients. But remember one thing, producers don't send the data to the recipient address. So let me give you an example again. So in the restaurant example, is there any direct communication between you and chef? No. Most likely there won't be any direct interaction between the customer as well as the chef or the cook, right? So you have placed an order, someone else will pick up the order from you, pass it on to the cook or chef, and then the food could be delivered to your onto a table. But again, is there any direct communication between you and chef? No, not at all, right? The same thing is happening here. Producers don't send the data to the recipient address. They just send it to the Kafka server or Kafka broker, and then the consumer can consume the data from the Kafka server or Kafka broker. So these are it will look like diagrammatically. Producer produces the data to the Kafka server, consumer consumes the data from the Kafka server. So this is the flow. You have this data. Producer is going to take each and every record and then produce it or send it to the Kafka server. Then the consumer will request for the message from the Kafka server. Kafka server will respond back with the required messages. This is the overall flow that we have got. Now let's talk a little bit about Kafka server or Kafka broker. Again, these are all like synonyms. So some people call it as Kafka broker, some people call it as Kafka server, some people even just call it as just broker as well, and some people even call it as agent or Kafka agent. All these are synonyms. So now why did they keep the name as Kafka broker? Because it's going to act as the message broker between your producer and consumer. There is no interaction between the producer and consumer directly. Producer produces the data to the Kafka server, and then consumer consumes the data from the Kafka server or Kafka broker. Now let's talk a little bit about Kafka brokers. So each Kafka broker will have a unique ID or unique number. You can see here, every broker will have a unique number. I will show it in hands-on shortly. But for now, remember that every Kafka broker is uniquely identified by a number or unique ID. Now let's talk about Kafka cluster. What is a Kafka cluster? Kafka cluster is nothing but group of computers that are connected together. Now, what is mean by Kafka cluster? Or if on each of these machines, if you install Kafka, then we are going to call it as Kafka cluster. So as you can see here, we have the Kafka cluster where you have multiple machines on which Kafka broker is installed. You might be seeing Zookeeper here. We'll talk about Zookeeper shortly. But for now, let's focus on Kafka cluster. Kafka cluster is a group of machines that are connected together. Now, let's talk about Kafka topic. So what is a topic in Kafka? Let me make it simple for you. Topic in Kafka is actually equal to a table in a database. If you take employee table in a database, employee table in a database will store only the employee related information. So similarly, a topic in Kafka stores only the related information. So conceptually, you can think of a topic in Kafka is actually equal to a table in a database. Now, so let's understand it from here. So Kafka topic is just an arbitrary name given to a data set. Basically, it stores only the respective related information. So we better say that it is a unique name for a given data stream. So let's see this practically. You can see here on the left hand side we have producers, on the right hand side we have consumers, and we have Kafka cluster in between. Suppose let's say that I wanted to take the orders from Amazon. So as you know, Amazon operates throughout the world. So suppose let's say that I wanted to take all the orders placed by the customers all over the world, and we call it as global orders, right? I'm going to push all those global orders or the orders placed by the customers into this specific topic called as global orders. And there could be other topic, let's say the shipping information, all that is available in other topic, right? You can think of it as this, right? So basically the concept is simple. The Kafka topic is used to store the related information as a whole. You can think of a topic in Kafka is similar to a table in a database. Now, I told that Kafka is a distributed real-time streaming platform, right? Now, why did I call it as distributed? Because if you remember, we have uh, we have the concept called as uh, let me go back here. We have data frames in Spark, right? So in Spark, data frames, or RDDs are broken down to get the partitions. Similarly, in Kafka also we have the similar concept. So we have the topic broken down into partitions. You can see here we have three Kafka brokers in the Kafka cluster: broker 101, broker 102, broker 103. And we have two topics: topic A with three partitions and topic B with two partitions. Now we have to distribute this data among these three Kafka brokers. As you can see here, topic A have three partitions totally. You can see that partition 0 is available on broker 101, partition 1 is available on broker 103, partition 2 is available on broker 102. So the data is distributed such that three partitions of topic A are spread across these three Kafka brokers. And then topic B have only two partitions. You can see that topic B partitions are available on broker 101 and then broker 102. So the data is distributed and broker 103 doesn't have any topic B data because we have just only two partitions for topic B. So that's how data is distributed in Kafka as well. Now, each Kafka broker is also called as bootstrap server. That means you only need to connect to one of the broker and you will be connected to the entire cluster. So as you can see here, if you take this Kafka cluster, I have totally 5 Kafka brokers, and we wanted to connect to Kafka cluster. If you just connect to one of these Kafka brokers, that's all. You will be able to get the entire information about your Kafka cluster, such as how many brokers are there, how many topics are there, how many partitions are there. All such metadata information can be fetched if you are able to just connect to one of the Kafka broker, because each broker is aware of all the information about all the other brokers as well. Now, again, if you remember, in HDFS, right? In HDFS, how are we getting the fault tolerance capability with respect to the replication factor, right? Replication of blocks, right? So the default replication factor was default replication factor in HDFS was 3. That is, every block is available in 3 copies. So in Spark, how are we getting the fault tolerance capability? In Spark, we get the fault tolerance capability by using lineage graph. Now, in Kafka, we also get the fault tolerance capability because of the replication of partitions. As you can see here, topic should have the replication factor greater than 0, usually between 2 and 3. So you can see here I have my Kafka cluster with 3 Kafka brokers. So this way, if a Kafka broker is down, another Kafka broker can serve the data, right? So you can see the topic A have 2 partitions and the replication factor is 2. So 2 multiplied by 2, 4. Totally we'll have 4 partitions. As you can see here on broker 101, partition 0 first copies is here. On broker 102, partition 0 second copy is here. So similarly on broker 102, partition 1 first copy is here. On broker 103, partition 1 second copy is here, right? Now what is the advantage if you have the setup like this? Suppose if you lost any broker, let's say broker 102 is down, we can still get the required information because topic A is a combination of partition 0 and partition 1, and we can get the same with the help of broker 101 and broker 103, because broker 103 have got partition 0 and broker 103 have got partition 1. So that is advantage that we are going to get. So we get the fault tolerance capability in Kafka because each and every partition is also replicated. And as I told, topic in Kafka has been broken down to different partitions, right? And there comes the concept of leader. So what is a leader and why do we need it? I will again give an example. Suppose let us say that you are working in your project and your project have one technical lead. So imagine that there are total 10 members in your team and there is one technical lead for your entire team. So generally, if you have to interact with other teams, most likely your technical lead will be interacting with other teams, right? So if you think of your entire team as a single partition, your technical lead is going to act as a leader for the entire partition. The same concept is applicable here. So we will have a leader for each and every partition. So at any point, at any time, only one broker can be a leader for a given partition. Only that leader can receive and serve the data for a given partition. So the other brokers will synchronize the data. Therefore, each partition has one leader and then multiple ISR. ISR is nothing but in sync replica. It is nothing but followers. As I told, in a given team, you have one technical lead and multiple team members. You can think of team members as followers. And the same terminology in Kafka world is called as ISR, in sync replica. So if you understand it practically, if you understand it diagrammatically here, I have a Kafka cluster with 3 Kafka brokers, broker 101, broker 102, and then broker 103. I have topic A with 2 partitions. You can see topic A have 2 partitions and the replication factor is 2. Totally we have 4 partitions. all these partitions are spread across. So you can see partition 0 first copy is available on broker 101. Partition 0 second copy is available on broker 102. And partition 1 first copy is available on broker 102. Partition 1 second copy is available on broker 103. So for the partition 0, the leader will be broker 101, and the other partition is going to act as a kind of in sync replica. Similarly, for the partition 1, the leader will be broker 102. Others are going to act as in sync replica. So at any given point of time, only one broker can act as leader for a given partition. Let's talk about Zookeeper. So one interview question here: can we start Kafka without starting Zookeeper? That is the common interview question. Answer to that question is no. We cannot start Kafka without starting Zookeeper. So Zookeeper plays a key role in Kafka. So Zookeeper is going to act as a coordination service in Kafka. Now, when I say coordination service, what does it do? So Zookeeper manages the brokers. That is, it keeps a list of all the brokers, and then Zookeeper helps in performing the leader election for a given partition, for the partitions. And Zookeeper also sends a notification to Kafka in case of any changes. The changes can be if you create a new topic, or if any of the Kafka broker goes down, or any of the new Kafka broker comes up, or if you delete a Kafka topic and all that. Important point to keep in mind is you cannot start Kafka without starting Zookeeper. That is not valid. Now let's talk about the concept called as offset in Kafka. So what is offset in Kafka? So before talking about offset in Kafka, if you remember when we spoke about Python, we have a collection called as list, right? So list store the elements in a sequential fashion, and each element in a list can be uniquely identified by an index. The same concept is applicable here. So let me do one more thing. So to give you even more clarity, in Spark, what is the hierarchy? We have Spark job. Job contains stages. Stages contain tasks. Right. So similarly in Kafka, if you relate it, you have topic. Topic has been broken down into partitions, and each partition has been further broken down into multiple messages. As you can understand it here diagrammatically, this is how a partition will look like. Each partition contains multiple messages. So each message is uniquely identified by an offset. So what is offset? Offset is nothing but a sequence number of a message in a partition. This number is assigned as soon as the message arrives in the partition. And once these numbers are assigned, they will never change. They are immutable in nature. So a sequence ID given to message as soon as they arrive in the partition. So you can think of in Python as a concept called as list, right? So you try to uniquely identify a given message, given element in a list based on index. Similarly, in Kafka, so in a given partition, you'll have multiple messages. To uniquely identify a given message, you have to know the offset information. It is just nothing but a number. Now there might be one interview question here. The interview question goes this way, right? So what is a global unique identifier of a message? But before that, understand one thing. This sequencing means that Kafka stores the message in the order of arrival within the partition. The first message gets an offset 0, the next message receives an offset 1, and so on. But remember, there is no global offset across the partitions. So offsets are generally local to the partitions. So if you have to locate a message, you need to know three things. That is called as global unique identifier. What is the meaning of global unique identifier? How can you locate a given message? To locate a given message, you need to know three things. You need to know the topic name, because there might be multiple topics in a given Kafka cluster. And then there might be multiple partitions in a given topic, so you need to know the partition number. And there will be multiple messages in a given partition, so you need to know the offset number as well. So if you can have these three things, then you can directly go ahead and then look at a given message. So that is a global unique identifier of a message. So this is how it is, right? You can see Kafka topic contains multiple partitions, and partition contains messages. Each message is uniquely identified by a given offset number. So now let me talk about consumer group in Kafka. So I'll explain this with the help of an example. Suppose let's say that you went to Walmart to buy some groceries or products, and in Walmart there might be multiple counters, right? There might be multiple billing counters. So our goal is to, if you can think of each of these billing counters as is on the left hand side, we wanted to transfer all those billing invoices to the data center which is on the right hand side. So we need some transportation mechanism using which we can transfer all the billing invoices on the fly automatically. That's where we can use Kafka. By the way, this is the logo for Kafka. So you can use Kafka as a data transfer tool or data ingestion tool. So we can transfer this data from the billing invoices to the data center, right? So each of the billing invoices, billing counters actually going to act as a producer, because each billing counter is generating or producing a message, or when I say message, it is nothing but a billing invoice. So that's why it's going to act as a producer. So Kafka cannot directly interact with data center, hence we have to have a consumer application which will read the data from Kafka and pushes it onto the data center. Suppose if you take a weekdays, in the weekdays the data is less, right? Because there would be less customers and there will be less billing invoices getting generated. But if it is weekend, there might be huge number of customers, and each of the billing counters must be generating huge amount of billing invoices. It is tough for the consumer to handle all the huge data that is coming at that time, especially during the weekends. To solve this problem, we have the concept called as consumer group. Now the consumer group, as the name suggests, bunch of consumers, they're going to act as a group. And their role is to load balance. Load balance is nothing but, instead of having one consumer which is getting overloaded, we will have multiple consumers in the multiple consumer group. Each will take the billing invoice and then pass it on to the data center. So this concept is called as consumer group in Kafka. It is basically used to balance your load on the system. Okay, now let's actually get into the hands-on. So now I'm going to go ahead and try to show the hands-on of Kafka. I already have Kafka installed on my machine. I am going to upload a recording using which we can refer and then install Kafka on your machine. So for now, I'll go ahead and show my Kafka installation on my local machine. So it's in C drive Kafka folder. This is where my Kafka binaries are available. And if you refer to the recording which I'm going to upload, you have to create two folders under data folder called as Kafka and then Zookeeper. Under C drive, Kafka folder. Within Kafka folder, create data folder. Within that, mention these two. Create these two, Kafka as well as Zookeeper. If you refer to that recording, you'll get a clear idea. Now to start with, let us first see how to start the Zookeeper. To start the Zookeeper, I am going to basically go to this folder called as bin folder. Bin stands for binaries. And as I'm using Windows, I'm going to go to the Windows folder here. But if you're using Mac, you can use the shell scripts that you have here. But I'm using Windows, hence I'm going to go ahead and log in into the Windows folder. Here you can see a lot of batch files. So the equivalent of shell script on Windows is nothing but batch file. You can see the type is showing as Windows batch file. To start Zookeeper, we already have a batch script. I'm going to use that. So you can see Zookeeper server start. This is the script that I'm going to use. So open the command prompt. What you can do is just You can open the command from here as well. I'm just going to type cmd. Enter. This will automatically open it in the C drive, Kafka, and then bin folder. Okay, so now I'm going to start my Zookeeper. So let's start Zookeeper. Zookeeper hyphen server hyphen start.bat. Hit enter. So you can see that you cannot start Zookeeper as it is. You have to pass the Zookeeper configuration file also, such as zookeeper.properties. So where can I find the configuration file of Zookeeper, such as Zookeeper.properties? It is available under Kafka config folder. So open the zookeeper.properties file here. Open with Notepad++. So you can see that I have opened this file. So this is the configuration file of Zookeeper. The name of that file is zookeeper.properties. So I'm going to pass this as well. So let's do one thing. You can even open this from the same path. So I'll go to the config folder from here. I'm just going to say zookeeper hyphen server hyphen start dot at, and then pass your properties file or the configuration file of Zookeeper. Enter. So this should start the Zookeeper for you. To confirm, what you can do is you can actually open another command prompt, type JPS. Type JPS. JPS basically stands for Java process. If you can see quorum pair main, this is nothing but my Zookeeper, right? So Zookeeper is running, and also you can figure out the port number on which Zookeeper is running. Let me show it here. You can see Zookeeper is running on the port 2181. And where can I find this port number information? Open the zookeeper.properties file. Here you can see the port. Client port is 2181. Hence, Zookeeper is running on the port 2181. Now let's start Kafka. Again, to start Kafka, we have a built-in script. I'm going to use the same. Go to the bin folder. Go to Windows folder. You have Kafka server start. This is the script that I'm going to use to start my Kafka. Again, we have to pass the configuration file of Kafka, so which is available under config folder. The configuration file of Kafka is nothing but server.properties. Open this with Notepad++, and this is the configuration file of Kafka. Right? So now let's go back and try to open another command prompt. And here I'm going to say Kafka hyphen server hyphen start.bat and pass your configuration file, which is nothing but server.properties. So now it should show as Kafka server started. I'm just looking for the same. Yeah, have a look here. Kafka server ID started, and you can say ID is showing as 0. So what is this ID showing as 0? Let's go back to the server.properties. You can see that, as I told, every broker will have a unique ID, and for this broker we have the broker ID as 0. So broker.id equal to 0. This is nothing but the ID of the broker. This must be set to unique integer for each broker. So that's what this number, Kafka server ID equal to 0, is nothing but. And what is the port number on which it is running? You can see that it is running on the port 9092, right? And if you can go back here and you can look at the port number, you can see that port number is 9092, right? 9092. And then it will try to connect to the Zookeeper on the port 2181. So if you can scroll down, you can see As we have started Zookeeper on port number 2181, Kafka also will try to connect to the Zookeeper on the port 2181. And to confirm that Kafka is running, you can just type JPS again. You can see Kafka. You have both Zookeeper running and Kafka running. Now let us go ahead and then see the list of all the topics. So let's see how to see the list of all the topics. I'll again go to the Windows folder. I have this script called as Kafka topic script. This is what I'm going to use. So let me open my command prompt here. I'm going to say Kafka hyphen topics.bat. Hit enter. First, let's try to understand what are the required parameters for seeing the list of all the topics. Scroll up. So you can see that using this script, you can create a topic, delete a topic, describe a topic, or change a topic. So now let's see the required parameters. You can see this is showing as required. So we have to mention the Bootstrap server. So Bootstrap server is nothing but the Kafka server onto which if you wanted to connect to. Scroll down. So that is a mandatory parameter. And apart from that, we are going to also mention -f list to see the list of all the topics. So let's do that. -f bootstrap-server. So it should be localhost colon 9092. As I told, Kafka is running on the port 9092. We have to mention the same port number, right? I'm going to mention the same port number here. And then we have to mention -f list so that it will give me the list of all the Kafka topics. So there is nothing. We have just started. I don't have any topics right now. But now I'm going to go ahead and then create the topics. To create the topic, I can use -f create. That will create a new topic. Also, we have to mention -f topic and mention the topic name that you wanted to create. So let's do that. Create -f topic and topic name. Let's say the topic name is sample. So this is the topic that should be created shortly. So give it some time. Uh, so this has created a topic called a sample. To confirm, just use up arrow on the keyboard and try to see the list of all the topics. You can see that we have a topic called a sample created, right? Now we have the topic created. Let us describe this topic. So to describe this topic, I can use -f describe. That will give me the list of all the details for a given topic. So let's do that. I'm going to mention -f describe, and also I'll have -f topic and then the topic name. So you can see that we have the partition count as 1, but we haven't mentioned the partition count as 1, and we haven't mentioned the replication factor as 1. Where are we getting these values from? We are getting these values from the Kafka configuration file. If I can scroll up here, you can see the default number of partitions is nothing but 1, right? And also the default replication factor is also 1. So if you don't mention anything, it will take the default values. Hence, it is showing us topic name is sample, partition count is 1, replication factor count is also 1, right? And you can see that it is showing us partition 0, leader 0, replica 0, and ASR 0. So what is the meaning of this 0? This 0 is nothing but the broker ID. If you can scroll up, this is the broker ID that is actually being represented here. As we have only one Kafka broker, the same is going to act as a leader as well as follower, that is in-sync replica. Now we have seen how to see the list of all the topics, and we have seen how to create a topic. We have seen how to describe a topic. Now let us see how to produce the data into this topic. To produce the data into this topic, I'm going to use Kafka console producer here. So let's see how to use this Kafka console producer here. Kafka console producer. Hit enter. Now scroll up, try to understand about the script. So you can see that there are some missing options. So you have to pass the missing required options. What is the mandatory parameter? You have to pass the bootstrap server in this form. You can see host colon port. That is the mandatory parameter. And what else is mandatory? And then you also have to mention the topic name or the topic ID into which you want to produce the message into. So let's mention those two. Hyphen bootstrap server. So it's going to be localhost colon 9092 topic name is sample. Enter. Now if you see this greater than symbol, then the producer is running. To confirm, what you can do is you can type JPS again. You can see console producer here, right? So my producer is running. I can go ahead and produce the data. Hello world. So I have produced two messages or two records. I would like to leave this producer tab as it is, a producer terminal as it is. I'll open a new tab to start consuming the data. So to consume the data, I have another script called as Kafka console consumer. This is what I'm going to use. So I'm going to open one more tab or one more command prompt. I'm going to first see how to use this Kafka console consumer. You don't need to by heart any commands here. You try to understand it from the documentation that is available, right? We don't need to by heart anything. So if you can scroll up, so this tool helps to read data from Kafka topics and outputs it to the standard output. You can see that you have the mandatory parameter as hyphen bootstrap server. And then what else is mandatory? Of course, you have to mention the topic name from which you wanted to read the data from. So I'm going to mention the topic name also. So let's mention those two. So I'm going to mention hyphen bootstrap server and then the topic name. Hyphen bootstrap server localhost colon 9092 hyphen topic name is sample. Producer is running. Let's go back here, type JPS. My consumer is also running, right? So now, but I'm not seeing any messages because have a look here. I have produced two messages, but I'm not seeing anything here. Let's do one thing. Let's send some more records. Let's pass some color names: red, green, blue. Now I can see those records, right? But what about the old ones? I have passed two old records, hello world, but I'm not seeing them when I try to consume the data, right? So what can be done to read the entire data right from the beginning? So to stop the console consumer, I'm going to use Control C on my keyboard. Type Control C twice and type Y. Basically, you are going to stop your console consumer. To confirm, you can type JPS. I don't have console consumer running now. Now I can go back and I will start the console consumer once again, but this time I'm going to mention hyphen from beginning. So now why do we need to mention this hyphen from beginning? I will show that. So if I can scroll up, you can see we are trying to check the documentation of Kafka console consumer. You can see this option called as hyphen from beginning. So by default, this value, so if the consumer doesn't already have an established offset to consume, so basically why do we need to use this option hyphen from beginning? because there is something called as offset. Have a look here, offset. By default, it will show only the latest data. So that's where it was able to consume only the latest data from the producer, but not the old data. So if you don't give that hyphen hyphen from beginning, it will show the latest data only for you. But now here in this case, we wanted to read the data entire from the beginning. Hence, if you set from beginning, automatically this hyphen hyphen set value will be set to the earliest. Earliest is nothing but it's going to read the data from the first. Let's do that now. Now you should see the entire data right from the first. Now you can see that we have the data, everything from the first. You can see hello world, red, green, blue. Let's do one thing. Let's push some more records. This time I'm going to pass month names. Jan, Feb, March. Hit enter. You can see I can see the data here. So that's where you can start consuming the data from the beginning, and you can also see that latest data is also showing up now. Now let's go back and stop the console consumer. Use Control C, type Control C twice and type Y. I've stopped my console consumer. I'm going to stop my console producer as well by using Control C, type Y. To confirm that both are not running, you can type JPS again. I don't have console consumer or console producer running. Right? Now let's do some experiments here. So let's actually go ahead and try to produce the data into a topic which doesn't exist. Let's go here. Let's first see the list of all the topics. I don't have any topic apart from sample, and this consumer offsets is automatically created by Kafka for us to maintain all the metadata information. We will not worry about this, but understand that sample is the topic that we have created. Now I'm going to produce the data into a topic which doesn't exist. So basically I'm going to use my producer script here to produce the data into a topic called as test. But do we have any topic with the name called as test here? I don't have anything, but let's try. Hit enter. It's not throwing me an error. If you can go back here, if you can type JPS, I can see that console producer is running. Let's push some data. Let's say hello. You can see that for the first message you are seeing some warning. And then if you say hello again, it's not throwing any warning for the second message. Right? Now let's do one thing. Let's start the consumer on this topic. You can see that we're able to read the data. It's showing us hello again. So basically, even though it is producing the data to a non-existing topic, this is not suggested. Always the best practice is to create a topic and then start producing the data. Okay. Now I'm going to stop the producer by saying Control C, type Y. Then I'm going to stop my control consumer, also Control C, type Y. And I'm going to stop everything basically now. I can close this command prompt. I can close this command prompt, and I can stop the Kafka first. Kafka server, Control C again, type Y again, and close this. And I'm going to stop my Zookeeper also at the last. Control C, type Y. Close this command prompt. Now go back here and type JPS. You can see there's nothing running right now. So where all the data is stored? So if you can go to C drive Kafka folder, you have the data folder. Go to Kafka folder here, and you can, if you can scroll down, you can see that we have created topics such as sample and then test. So we have created sample with just one partition. Hence sample -0 is nothing but This is partition 0. Let's go inside this. Now you can actually open this from the git bash here. Let's start looking at the contents of each of these. One second. Let me do one thing. Let me try to copy this. Right click copy. Right click and paste it. And you can see that the actual data is stored here, stored in the .log file. Of course, you cannot read it because this is binary form, but you can see that hello world, green, blue, etc. This is where the actual data is stored in the .log file. What is sample hyphen 0 here? 0 is nothing but your partition. Okay, I think this is actually enough to get started on Kafka. So we will again meet at 9:30 p.m. today at 9:30 p.m. EST, or it is actually at 7 a.m. IST Monday. Okay, so here we are going to talk about the project with a combination of Kafka plus Spark structured streaming. So this will be our last class. Okay. Okay, guys. So if you don't have any further questions, let's meet at 9:30 p.m. EST today, which is nothing but Sunday. Okay. See you then. Bye bye.